Hello everyone, welcome back to my YouTube channel, General Technology Knowledge. Today I would like to show and share about how to use the PLC S7-200 CPU 226CN and EM231CN 235CN connect with the Pt-100. It means that the temperature sensor and connect to the control valve by using the analog output. Okay, so before go to create the program, I would like to explain a little bit about the wiring diagram of this module. Okay, so first here is the supply 220 volt AC connected to the circuit breaker and supply to the PLC. Okay, and if we provide 220 volt AC, we will got 24 voltage from this terminal. Yes, that mark like this. It has ML plus and ground. Yes, so we can take the 24 voltage from this terminal to connect another expansion module like this. Okay, and here is the analog input module that we can call EM231CN, and here is the analog input channel number 1. Totally, if we choose EM231CN, we will got 4 channels of analog input. Channel number 1, we will use 3 terminals. Channel number 2, 3 terminal more. And channel number 3, 3 terminal more. And the last one is channel number 4. We will use 3 terminal more. Okay. And here is the analog input and analog output the same. It means that this module we can use 4 channels of analog input and 1 channel for analog output. Okay, so actually we can also don't use this one, we just use EM235 and then we can connect the analog output and input the same card. Okay, but in this section I just show and share about how to connect this module. Okay, and here is the Pt-100 that I will use 3 wires for connect to the temperature transmitter, and then it will generate the current milliamp for 2 milliamp from this terminal to connect with the PLC. Okay, and for this one we can set point to control the control valve by using the 4 to 20 milliamp or 0 to 20 milliamp to here, and then it will generate to this one also. Okay, so in this section I just show how to create the program for testing, and then in the next topics I will show and share about how to create the control. Yes, it means that we can set the PID control from the temperature to open the valve or something that we can do also. Okay, and in this section I will use software Simatic WinCC Step7 MicroWin version 4 series page 9 by using the PPI cable connect from my PC to the PLC. Okay, so this is the concept of this section, and Before create the program, make sure that we can wiring of this module. Otherwise, we cannot test this module. Okay. And I will explain more about the deep switch of this module also in the next step. Okay. So first, let's go to our software, Step7 MicroWin version 4 series page 9 to create the scaling or some program block to uh, control this module. Okay, so let's go. Okay, before go to create the program block, yes, by using this software, I would like to show and explain a little bit about the deep switch of the analog input and output module. Yes. So first go to the analog input module. Yes. EM231 analog input module, and here is the wiring diagram. Yes, that I already explained. And here is the analog input module and output module. Yes, diagram. And the next step, we will go to the setting deep switch. Yes, so here is the setting configuration switch of the module EM231. Yes, so we can use 0 to 10 volt, 0 to 5 volt, or 0 to 20 milliamp. Yes, by follow the deep switch. Yeah. So first, if we would like to use the 0 to 10 volt DC, we can choose on for deep switch number 1, choose off for deep switch number 2, and choose on for deep switch number 3. Okay. And one more configuration, if we would like to use 0 to 5 volt or 0 to 20 milliamp, we can also deep switch number 1 is on, number 2 is on, and number 3 is off. Okay, and this is a unpolar, and this is a bipolar section. Okay, so normally I use this setting. Yes. And the next step, here is the deep switch configuration for EM235 module. So right now I will use 0 to 20 milliamp. Yes. So I will choose the deep switch number 1 is on, deep switch number 2 is off, deep switch number 3 to number 5 is off also, and then deep switch number 6 is on. Okay. So it's very important for deep switch configuration. Yes, otherwise we cannot test this module, because if we wrong selection, we will cannot see the raw value of this module. Okay, so it's very important for this deep switch, right? So the next step, let's go to the program. Okay, so first we need to create the scale. Yeah, here, because our PLC is 0 to 20 milliamp, right? And our transmitter output of transmitter is 4 to 20 milliamp, but the scale of the PLC is 0 to 20 milliamp. So we should convert by using the scaling. Yes. So first we need to create the scaling, and second we need to create the analog scaling, and the third we will create the analog output scaling. Okay, totally 3 blocks that we will create. Yes, so let's go. Okay, first open software Step7 MicroWin version 4 CV page 9. Yes, and then first go to communication, check between our PC and PLC. So right now I already connected the PPI cable from my PC to the PLC CPU, and then we can click here, double click to refresh. Okay, and then right now it detects one CPU 226 CN. Yes, and then we click OK. So to create the scale, first we need to insert the subroutine. Yes, here. So I will insert the subroutine because totally we have 3 subroutine, right? Analog input scaling, and analog output scaling. Okay, so the first one is scale, and the second one of subroutine is analog input scale, and the third one is the analog output scale. Okay, so we need to create the scale first. Okay, I will zoom a little bit. Yes, zoom in a little bit, maybe 8. Yes, so go to scale of subroutine, and then for parameter of subroutine we need to use this one that I already summarized in the Excel file. Yes, so we need to use this formula: output equal input minus low scale in multiplied by high scale out minus low scale out divided by high scale in minus low scale in and plus low scale out. Okay, and here is the data that I already created, and we can simulation. Example, my input here, and the high scale input around 22,000 for S7-200, and this one from 0, and high scale out that we will got around something, example around 100 something. So if we write the input, example 0, it will 0 also. Yeah, if we write 1600, yes, we will got 50 because the rank is 0 to 100. Yes, so it is the 32,000 divided by 2, so we will got 50. Okay, so we will use this one. So we need to create the 6 parameter, right, in the block. The first one is input, second is high scale input, low scale input, high scale output, low scale output, and the output is the result. Okay, so let's go. So here is the row of input. So actually we can write input, and the data type is real. Yes, so we can comment anything. Example, input raw data. Yes. And the second one is high scale input, right? So high scale in, it is the real also. So we can command high scale input. And the third one is low scale input. The data is real also, and then we can command low scale input. And the fourth is high scale out. The data is real also, so high scale output. And this one low scale output. The data is real also, and we can command low scale output. And the last one for output, right? So this is the output, so we can write output, and it is the real also, and we can command output value. Okay. So let's go to see the formula. Yeah, here is the formula. So the first one, we need to calculate between input and low scale input, right? So actually we can copy this command to here, easy to understand. Yes. So this one is input minus low scale, right? Input minus low scale input. Yes. So low scale in. Yes. So the first one, we need to create the always on contact. So SM0.0, otherwise it will error. And then we will use the subtract, right, between input and low scale in. Okay. So go here and then sub real. Yes, here. So we will take input. Yes, we can tie input minus low scale input, right? So L scale in. Okay. And then the output is we will insert the temporary value. Yes, for this variables. Example, temp1. So it is the real also, right, for data type. So here I can choose temp1. Yes, it is the local variable. Yes. And the second block, we need to create the subtract also, right, between high scale out minus low scale out. Okay. So we can go here and subtract. Yes. So this one between high scale out. So high scale out minus low scale out, right? So low scale out. And then we will insert one more variable. Yes. Example temp2. And it is the real also for the data type. So here we can use temp2. Okay. and then we will continue to use, right, the multiply, right? So we can use multiply real, yes, okay, like this, and then we can multiply by this one, yes, and this one, and we need to create one more temp, example temp 3. Data type is real also, so here we can type temp 3, okay, and then we will continue to use the subtract, yes, between high scale input minus low scale input, yes. So go to sub real, yes. Actually we can copy and paste from this one also, but here I just explain, yes, about how to write the block. Okay, so subtract between high scale input minus low scale input, right? So high scale in minus low scale in, and then create one more for temporary variable, yeah, temp4, and it is the real also for data type, so we can type temp4 here, yes, and then we will divide this one and this one, right? So we can divide real, right? DIY, sorry, div real, and divide this one and this one, and then we will got temp5, yes, it is the real for data type, and this one for temp5. Okay, and the last formula is plus by low scale output, right? So we can go to add, right, plus add real, and then add this one with the low scale output, right, here low scale output. Okay, low scale out, and then we will generate to the output, right? So here we can use this one, output. Okay, so that's all for create the block of scale, yes. Scale, this scale is used for input and output, yes. So if we would like to use this one, we can drag and drop from here, yes, to use, example here, yes, we will got like this. But right now I will go to create the analog input scaling first, yes, here. So here we can keep first, yes, and then we can save the project, otherwise it will lose something if any error. So example Pt-100 S7-200, okay, and if we compile we will got like this, okay, no error occur. So the next step we will create the analog input, yes. For analog input, let's go to Excel file here. So this is a formula of analog input module, yes. So the formula is output equal input multiplied by high scale minus low scale divided by maximum of raw data and plus by low scale. Okay, and here is the data that I already simulate. Yes, example, we set 0 to 100 of example 100% or 150 degrees Celsius something. So if we put the raw data, example raw data around 32,000, yes, okay, I will change this one because it is the formula for another PLC. So formula is 32,000, yes. So we will got 100% for output, yes. Okay, and if it divide by 2, example 32,000 divide by 2, yes, we will got 50% or 50 degrees Celsius something. So we will create the formula by using this. Okay, so I will copy this one and paste here, easy to understand and create step by step. Yes, so the first we need to convert. Yes, but before convert we need to create the parameters. So totally we must create the 4 parameter here. So input, the first one is in, and the data type is integer, right, from the analog input. Yes, so this is the raw data. Yes, raw data input, right? Okay, and the second we need to create the high scale. Yes, high scale, it is the real, so high scale. And the third one is the low scale, so low scale, it is the real also. We can comment low scale. Yes, and the last one is the output, right? So output we can put here, out, it is the real also, right? Output value. Okay, and for this row we need to create the temp. Yes, so first we need to insert the always on contact, so SM 0.0, and the second one we need to use the subtract, right, between high scale and low scale. So we can use sub real. Yes, so this one high scale minus low scale. Yes, and then we will create the temp variable, example var1. So this one should be real. Yes, for data type. So here I can use var1. Okay, and then we will multiply by input, right? But the input is the integer, right, from the analog input. Example AIW0, AIW2, AIW4 something. So we need to convert from integer to real, right, before calculate this one. So we can copy this one to here, and here we can convert by using the integer to double integer, right? Because we cannot convert directly from integer to real, so we must convert from integer to double integer first. So this one is int, so we can use int, and then I will connect this one, yes, and then I will create the var2, and the data type is double integer, right? Because we convert from integer to double integer, so this one should be dint, or we can choose like this example, yes, you can click the drop down and then choose this one. So var2, okay, and then I will convert from double integer to real, right? So di to real, yeah, this one, and then copy and paste this one to here, and I will got one more for var3, and the data type is real, right? Because we convert from double integer to real. So here is var3, yes, and then right now we already convert from input integer to real, then we can use this formula, okay? So the next step we will multiply by this one and this one, so we can use multiply real, so real, yes, between this one and this one, yes, and then I will got var4, and the data type is real, so this one should be var4, yes, and I will divide this one by 32,000, so 32,000, so I can use divide real. Actually this one we can change followed by our PLC scaling, example 4 to 20 milliamp, or 0 to 20 milliamp, or 0 to 5 volt, so we can create this scale, okay? So I can copy this one to here and create one more for temp, so var5, it is the real also, yes, and here I can use var5, and the last step is plus by low scale, right? So here I can use add real, and this one plus by low scale, yes, so low scale, okay, and this one for the output, right? It is the result here, so we can write out, yes, this one, so we can compile, okay, no error occur, yes. So right now we already created one more block for analog input scaling, yes, so we can drag and drop to use if we want, like this, okay. And the next step we will create the analog output scaling, right? Okay, let's go to Excel file for analog output scaling. So here is the formula for analog scaling, and I already created the formula. So the formula is output equal the maximum of raw value, yes, multiply by input minus low scale, and divide by high scale minus low scale. Okay, so we can copy this formula to our program. Yes, so we have 1, 2, 3 and 4 parameter, right, that we need to create here. So the first one is input, and the data type is real. Yes, the purpose is we need convert from real to integer, because when we set point example 100.5% or 95.5% something, it is the real, and it will generate automatically to a milliamp or volt of analog output, right? So we need to convert from real to integer by follow this formula. Yes, so input is the real, so input value, and the second is high scale, it is the real also, so high scale. Okay, and the third is low scale, it is the real also, so low scale. Okay, and the last one is the output, right? So output, it is the integer, right? So output, so first we need to convert from input minus low scale and then divide. Yes, so we can use subtract. Okay, so sub real between input and low scale, right? So low scale. Okay, and then I will create the temp example value 1, it is the real for data. So here I can write value 1, and then we will use the multiply, right? So multiply real, yes, multiply by this one, and maximum, yes, of raw value. So example 32,000, yes, and then I will create value 2 for temp 2, and it is the real also. So value 2, yes, and then we will divide this one by high scale minus low scale, right? So we can copy this one to use. Yes, and don't forget use the SM0.0 for all way on. Yes, so we can use the high scale minus low scale. So high scale minus low scale, sorry, this one high scale, 8 scale. Okay, 8 scale, yes, minus low scale, and then I will create one more for value 3 for temp 3, it is the real also. So value 3, and then we need to use the divide, right, between this one and this one, right? So we can use divide real, and then I can copy this one to here and this one to here, and then I will got the temp 4, right? So value 4. This variable, everyone can create some variable that we want. Yes. So value 4. Okay. And this is a real. Yes. Real value. So we need to convert to the integer, right? Okay. So I will use the function truncate. Yeah. This one. The first we need to convert from real to the double integer, right? You can see the help by pressing the F1. Yes. This is convert from real to double integer. Yes. Here it is their function. Yes. So we can read, and then I will use one more for double integer value. Example value 5, and it is the double integer because we will convert from real to double integer and then double integer to integer, right? So this is the value 5. Okay, and then I will convert from this value to integer, right? So we can convert from the I double integer to integer because our analog output is integer, right? So I can copy this one. Yes, and here is the output, right? So we can use output. Okay, and we can compile and save the project. Okay, so no error occur also. So right now we already created scale in out, scale analog input, and scale output. So in the next step we will drag and drop this block to use. Yes. So first we need convert from the analog input to the raw value, right? So the first one we need to create the SM0.0 for always on, and then I will use the scale, drag and drop from here to here. Yes, and I already tested with my PLC. For the input I can use the AIW 0. Yes, sorry, it is the real. So I will convert from the integer to real first. Yes, so I will copy this one to here, and then I will convert the analog input to the real first. So here we can use the, so here we will convert from the analog input to the real value first. Okay, so I can use the DI, sorry, I to DI, convert from AIW 0 to the example this one y1. It is the double integer dint. Yes, so this is the y1, and the next step I will convert from double integer to real, so we can use di to real because the scale is real. Yes, for data type, otherwise we cannot use the integer to here. So I will convert this one to real. Example y2, it is the real, so this one is y2 va2, and then I can use this one to here. Yes, and then it not error occur. Okay, so for this PLC I already tested for high scale. It's around 32 something, so we can use this scale first because I already tested for my PLC 6382.0. Yeah, it means that 4 milliamp because our transmitter is 4 milliamp, so 4 milliamp around 6382 something. Yes, and we will got output that we need 2000 32,000. Yes, sorry, and start from 0 to 0. Okay, for low scale, and then I will use the another memory, example MD0. Yes, and then we will use the one more block for show the actual temperature, right? So I will use analog input block. Yes, from here. But here is the input for integer, right? So we need convert from this real to integer first. Yes, so I can copy, cut this one, and then we can convert this one by using the function trunc. Yes, convert this one to the, it means that convert from real to double integer, and then convert from double integer. Yes, to double integer, right? So I can choose the va3 double integer dint. Yes, so va3, and then actually here we can use another memory that we want. Example AC0. Yes, and then we can move. Yes, and then we can move. Yes, use mover. Okay, we can move it from here. Example VW0. Yes, so we can move it from this one to the scale. Yes, here. Yes, and then this temperature transmitter, I already set the scale. Yes, So 0 to 100 degrees Celsius, and this is a memory, another memory, example MD4, yes, for real, MD4. Okay, so if we download, we can got the actual value of temperature here. So I will save the project and then go to download. Okay, stop the CPU. Run the CPU and then we can online by pressing here. Okay, so right now the actual temperature around 24 something here, because the raw data around 12,000 something, yes, and I will show the actual temperature. It different around 1 degree Celsius, yes. Okay, let's see, here is the temperature around 25 degrees Celsius, and our PLC show around 24 something, so it error a little bit around 1 degree Celsius. Okay, and here is the connection that I already connected the milliamp to here, yes, to this terminal. And the next step, we will write the program for control the control valve, yes. So the actual temperature around 25, and here show around 24. It error accuracy around 1 degree Celsius, so no problem. So if we would like to adjust something to be the same, we can adjust here, yes. So the scaling is very important, that we can scale from another value to convert to another value. Okay, so the next step, we will use the analog out for test the actuator, right, to test this one, yes. So I can offline, and then we can comment analog output module to control the control valve. Okay, and here we can comment actual temperature, yes. So it's very easy if we created the scale of analog output. So we just drag and drop here, and then don't forget use the always on, so SM0.0, and here is the memory, another memory that we want to write the output, example MD8 or MD10, yes, and example scaling from the 0.0 to sorry, the high scale should be 100.0, because the control valve actually we can use 0 to 100%, yes. So we can set scale 0 to 100, and here is the address of analog output, right? So AQW0, right, like this. So we can save the project and then download to the PLC, and I will show and share about how to test. Okay, start the CPU. Okay, so right now it show around 0. Oh, MD10 is already used, right? So I will use another MD. Example MD12. Because MD10 maybe we already use, so it complete with another address. So we need to use another memory. Okay, MD12 is 0 right now, and the milliamp is show 0 also. Let me show. So here is the analog output terminal that I connect to the multimeter. Yes, because it just example. Example, this is the control valve. So we can set point from the touch screen or something here that I will show in the next video. So here we can write example 10%. Yes, let's see the milliamp is up to 10%. Yes, example 50%. Yes, 100%. Okay, 20 milliamp, right? So we can use this step to control the control valve. Yes, by set from the touch screen or something. Okay, but I will show in this step in the next video. Yes, about how to create the scale or create the touch screen by using the WinCC Flexible. Okay, so we need the feedback from the actuator to another channel of the analog input, right? So we must create the scaling also. So we should follow this one for feedback. So first we need convert from double integer to integer, right? Sorry, from integer to double integer, and from double integer to real, right? So we can comment feedback from control valve. Okay, so 4 to 20 milliamp, right? This one 0 to 20 milliamp. So here if we would like to convert something, example 4 to 20 milliamp, we can follow this step. Yes. So here I can copy, convert from integer to double integer, from double integer to real. So this one AIW6, because I use the last channel. So AIW0, AIW4, sorry, AIW0, AIW2, AIW4, and AIW6. So this one AIW6. And then this one I can create the VAR4, VA4. and this double integer, right? DINT. So VAR4 VA4, yes, and convert this one to real. So VA5, it is the real, yes. So VA5, and then I will do the scale, right? So scale, and don't forget use the always on, yes. And then we can copy from this one to here, yes. And then example MD12, this one I use 12 already, so MD 26, yes, sorry 16, and then I will convert, yes. So I can copy this one to here, yes. Then I will use this memory to here, example AC10, AC4, but actually we can use another address or another temp, yes. So in here I will be a 6 and use the temp, and this is a double integer, right? So DINT, so VA6, and this one convert from VA6 to double integer, right? Cannot use, right? AC2, we can test with AC2, example VW4, yes, and then choose the AIN, right? And then we can use the VW4, yes, and example MD 20, yes. So let's test together. Okay, let's online to see the status. So right now it show around 100%, because right now I select the milliamp to 20 milliamp. So if I adjust, yes, let me adjust. If I adjust the milliamp, yes, let's see here. Okay, around 0%, yes, it is the feedback. This is around 25%, 50%, 25%, and 100%. Okay, so the raw value will change, yes, if we select. Okay, so that's correct for our scaling. So thank you very much for watching my video, and if everyone have any question, please kindly drop comment under my video. I will reply soon. And I would like to say sorry if I have a mistake in this video also. And in the next video, I would like to show and share about how to bring this signal to show on the HMI. Yes, by using this block. Okay. And I would like to request all of you to like, share, and subscribe my video also to get more notification and more new videos that I will create step by step. So in this time, I would like to say thank you very much again and see you next videos. Bye bye.